Evaluate the limit as x tends to infinity of the quantity x squared plus 14x times e to the minus x. So let's start by writing this thing as the limit again so that we can run through the Plyer's algorithm. So we have 14 x squared plus 14x times e to the x. Now the first thing is to try plugging in x going to infinity. So we're going to have infinity plus an infinity times e to the minus infinity. The expression on the left is infinite multiplied by 0, and so that makes this a type B indeterminate form. Now the trick for a type B indeterminate form is to rewrite the original expression as a fraction. So we're going to have the limit as x tends to infinity, and we need a giant numerator and denominator. Well, obviously, e to the minus x can go downstairs, and we'll keep x squared plus 14x on the top. Now we'll try again. If we plug in x going to infinity, we get an infinity plus infinity on the top, e to the infinity on the bottom. That's an infinite number upstairs and an infinite number downstairs. That's type A indeterminate, and that means we can hit it with the L'Hopital stick. So let's apply L'Hopital's rule. We'll keep the limit going to the same value, x tending to infinity, but we'll replace the top by the derivative of the top, and we'll replace the bottom by the derivative of the bottom, just e to the x, and restart the process. As x tends to infinity, we're going to get an infinity on the top, e to the infinity on the bottom, and that's still infinity over infinity, which is type A indeterminate again. So we'll smack it one more time with the L'Hopital stick. If we hit the limit one more time, we'll still have a limit as x tends to infinity. We'll replace the top by the derivative of the top, which is just 2. The bottom will still be e to the x, the derivative of e to the x. And now we're going to get 2 to the e to the infinity. That's 2 over infinity, which as a limit we interpret as 0. Since this is a number, it's also our limiting value. And so the limit value is 0.